first of all, I need an interaction with those who are participating here. So, if you have any doubt, don't hesitate to ask. Okay, I'm glad to clear your doubts. Okay, so my topic here is real analysis. So, in that real analysis, I'm more focused in continuous functions and those kind of things. And we have a lot of time. So, I'm like an introduction. I will just say how the real numbers and real analysis was constructed in the base of natural number. Okay, yeah. So basically, we know that real number is constructed from the basic thing called natural number. Okay. Anybody knows what is the definition for natural number? This is the starting point we going to look. Anybody? If not, means okay. So mathematician defines natural number. It is a set with one will be inside that set. Okay. So any and the second condition is if a number is inside a natural number, then x plus 1, the immediate preceded successor will be also inside that natural number. This is the basic definition for the natural number. Okay, so starting with this natural number, we are going to construct a number system called real number system. Okay, so I want to quote a thing by the mathematician Carnot. He says that the natural number is the thing that God given to us, remaining all number system or all things which are made by man. Okay, we only construct those things based on the natural number. Okay, so the definition of the natural number, it should contain one in it, and if x is belongs to that natural number, then x plus 1, that immediate successor, will also inside that natural number. This is the definition for the natural number. Okay, so from the natural number, it is not enough to mankind to work only with the natural number. We need a concept, and we borrow something. We want to give something, but we didn't give at that time. Means that is the thing we want to not know. So actually, natural number is not enough for us. Why? Because of the addition operator. Okay, so natural number with this addition, which is a semi-group. Semi-group means it satisfies closed state. If x and y belongs to that natural number, then x plus y will also belongs to that natural number. And second thing is associativity. X plus y plus z equal to x plus y plus z for all x, y, z belongs to that natural number. Okay, this two property under addition, the natural number is semi-group. But the second condition is that we need one element. We need an element which fix the thing, which means we need an element, call it as 0, such that e plus x equal to x. We need such an element. So from the natural number, we develop the concept called a whole numbers. Okay, and we know that the development of whole numbers is due to the Aryabhatta, who invented zero. Okay, so from the natural number, we are going to construct a whole number by adding a additional element called e, such that e plus x equal to x. Okay, and later we given a notation called e. We instead of e we are putting this notation using this symbol called 0. Okay, so to natural number we are going to add union one element called 0. So we constructed a whole number system which is natural number union 0. Okay, so we need actually whole number satisfies these three properties, but additional thing is that we need an inverse. What is the meaning of inverse? For every x in the natural number, we want to find a y that is also belongs to that set. Means here is natural number is not valid. So we need a set which containing natural number such that for every element in that set, we there exists a y in that set such that x plus y equal to 0. Okay, such a thing is not exist in natural number. So we need this property. So we are going to construct from natural number we are constructed whole numbers, and from whole numbers adding just a negative numbers we construct the concept called integers. Okay, so from this integer, the set is here is nothing but an integer. Okay, so in the integer, if we take any element, we can find an element in that set such that x plus y equal to 0. Later on, we denote this y by minus x. Okay, later on we denote this y by minus x and we call it as a negative numbers. Okay, like that we are constructing integers. From integer is also not necessary. Actually, this four property additional condition with commutativity x plus y equal to y plus x. This phi property satisfied this condition. So in z under addition is a abelian rule. Okay, so we are trying to do another operation called multiplication, or we call that dot operation. So we are going to complete that dot operation. So we construct the concept called Q. Okay, we are creating another number system to make this thing to be a ring or a group structure under the multiplication operation. So only we construct Z from Q from Z. Okay, so here Q is the final thing which satisfies all algebraic structures, but Q is not enough. Why Q is not enough? Anybody want to answer that? Why Q is not enough? Is there any doubts or anything you want to interact with me? Please.
Participants, if you have a doubts, please unmute and speak with the speaker.
Okay. Okay. Yeah.
It's not enough because of the irrational numbers.
Because of the irrational number. What is the concept of irrational numbers?
Rational. Square root of 2.
Okay.
5.
Okay.
5.
Okay. So we construct n, and then we construct a concept called whole number, integer, and q. Okay, but q is not enough. Why q is not enough? Why q is not the complete? Complete in the sense what? Q is not complete. Okay, so actually q is well behaved guy under addition and multiplication. Okay, so note, we want to note that addition, the negative operator is nothing but a multiplication, means inverse of the addition. Okay, so we are only focusing on addition and multiplication, not subtraction and division. Okay, actually, why? Because subtraction is nothing but x plus that inverse of that element, adding x plus that inverse of y. Okay, so addition is enough for us. So if you know about addition, we can just define multiplication. Similarly, if you know about if you know about addition, we can define subtraction. And if you don't know about multiplication, we can define division also. Okay, so Q under addition and multiplication, it is a well-behaved guy. Means what I meaning is, it is a ring in algebraic structure. We call it as a ring, and also it is also a field. Okay, so Q under addition and multiplication, which is a well-behaved guy. But so Q is well-behaved guy in algebraic structure, but there is more thing in Q. We can define an order in Q. Okay, so we can define an order. Say it as less than. Okay, so you know the order, no? So in this thing, natural number, whole number, and integer and rational. So there are order in this field. Okay, in this set there are order. So with respect to this order, Q is not well behaved. Okay, so for that they are using two concepts called upper bound and lower bound. A is bounded above. Bounded above if there exists a x in say Q such that a is less than or equal to x for all a belongs to capital A. And similarly, we can define the concept called bounded below, and we are defining a new concept called supremum of a set. Okay, the supremum of a set also called least upper bound of A. Okay, so Q fails to have least upper bound property. Okay, what is the least upper bound property means? Any bounded above set has an upper bound, means least upper bound means Q has a least upper bound property. Okay, so but Q does not has a least upper bound property. That is the thing which lag in Q under this order relation. Okay, but Q under addition and multiplication is well behaved guy. In Q under addition, that algebraic structure and all is all okay, but under this order relation, this less than order relation, Q fails to be complete because there exists a set which is bounded above but does not have least upper bound. For example, a set, the popular example is A is set of all x belongs to Q plus such that x square less than 2. So this set has a subset of Q which has a which is bounded above, but it fails to have least upper bound. Okay, so actually the proof will be if x is equal to supremum of A, they will prove that x square equal to 2. But in the rational number, there is no such element x which square will give leads to 2. So Q is not complete in the sense of order relation. Okay, so we want to make a completion of Q which has an order and also has a property called least upper bound property. Every bounded above set has a least upper bound. Okay, so only we are going to construct a concept called R. Okay, so Q is a well-behaved guy in addition and multiplication. Algebraic structure, there is no issue in Q, but there is an issue in order relation. Okay, there is an issue in order relation. So for that issue, we are going to construct a more bigger set called rational number, real number. So in that real number, it has an ordered property and every bounded above set has a least upper bound. So only we are going to construct R from Q. Okay. So the construction of R is two kind. Till now, there will be famous construction called Dedekind cuts and Cauchy criteria. Okay, or Cauchy construction. So constructing R, I will just give an outline for Dedekind cuts and also Cauchy criteria. Okay, yeah. So think this as a rational number. We know that rational number has a hole in between. So rational number has a hole in between them. So we want to fill that hole. Okay, we want to fill that hole. So what the mathematician called Dedekind is the first mathematician who show the existence of real numbers. Okay, from Q he constructed a real number, but in his construction he used Dedekind cuts. What is the meaning of Dedekind cut means? If we take a line, we can cut the line into two parts, A and B. If it is one, for example, this cut the portion is 1 means A is nothing but minus infinity to 1, B is nothing but 1 to infinity. So he defined 1 as the pair A, B. Okay, so the basic idea is he wants to cut the real line, and by using the rational thing, we want to define a new thing called real numbers. Okay, for that what he done means he cut the line into two parts and he defined one has this thing. For example, I'm saying that. So if you want to think one as a number, but in the construction of DD kind, he think one as a pair, A and B. Sorry. So he collect the set from Q only. So this is mean that set of all X belongs to Q such that X is less than 1 and set of all X belongs to Q that X is greater than or equal to 1. Okay, like that he divide the rational number. He divide a rational number like this and he call this as a cut. And this cut is named after him, that is DD kind cut. Okay, DD kind. So he is the first mathematician who shows the existence set. It is shown that there exists a set R which contains Q such that it is an ordered field. Okay, under that order, it has a least upper bound property and it is also algebraically closed. Okay, so and algebraically well behaved set R. This is the one of the kind that DD kind possesses, and other thing that Cauchy possesses is by Cauchy sequence. Okay, he defined a Cauchy sequence and he collects set of all Cauchy sequence on Q. So actually basic idea is he defined a sequence and he collect all Cauchy sequence subset of Q such that Xn is Cauchy. Xn is Cauchy. So he collect all Cauchy sequence and he defined an equivalent relation. Xn related to Yn if and only if Xn minus Yn tends to 0. So he defined this equivalent relation. You can show that it is an equivalent relation, and in he collect all equivalent classes. Equivalent classes. This classes is nothing but an OR. Okay, actually, what is the difference between DD kind and the Cauchy thing is that DD kind look all real number as a pair of DD kind cuts, but Cauchy defined it as a equivalent classes. Okay, so if you are taking an element, a number in or say 1. According to DD kind, it is a pair of set called cuts, but according to Cauchy, 1 is nothing but a class of sequence, Cauchy sequence. Okay, so there is a difference. I'm not going well into these two concepts, but I am saying that construction of you DD kind cuts and Cauchy. So these two mathematicians defined the theorem of real numbers. Uniqueness theorem for real numbers. If you are constructing a concept, means if you are constructing two sets which containing Q in it, R1 and R2. If we are constructing, because DD kind construct as a cuts, but Cauchy did by a classes. But these two sets are not equal, no. But we are saying it is in a real number. Why? Why? Because of this theorem. The theorem states that if you construct two sets R1, R2, which contains Q means there is a structure preserving bijection to Q. Okay, there is a structure preserving bijection from Q to Q1 and Q to Q2. So, if you are constructing two different sets which embedded Q as a subfield means the uniqueness theorem says there is a structure preserving and order preserving bijection between these two sets. This is structure preserving and order preserving bijection between R1 and R2. There is a theorem which guarantee that there exists a unique real number such that uniqueness in the sense if you constructing two different sets also there will be a structure preserving and order preserving bijection. Okay. So what is the meaning of structure preserving and order preserving means R1 plus dot R2 plus dot. Okay, if there is a function f which is from R1 to R2 means f of x1 plus x2 which is equal to f of x1 and f of x2. This we called as a group homomorphism under addition and under multiplication also x1 dot x2 equal to x1 dot x2. Both together this both we say this f function as a field homomorphism. Okay, this f is if this f is bijective and satisfying these two conditions and r plus multiplication R2 plus and multiplication which is a field means f is nothing but a field homomorphism and also the additional order preserving thing is nothing but if x1 less than x2 then the function output also f of x1 is less than f of x2. Additional thing is nothing but an order. So here also there will be an order. Here also there will be an order. So uniqueness in the sense of this function. Okay. So there exists if we construct two different sets which contains a copy of rational numbers or and which contains a copy of rational numbers and the set has a least upper bound property in an order relation means these two sets are unique in the sense there exists a function which is bijective, order preserving and structure preserving map. Okay. Anybody has a doubt, means having doubt in this thing? So the main thing is Diedekerr and Cauchy things of constructing a real numbers. It's two things are fundamental and basic in real analysis. So if you are interested to study Diedekerr, please refer Rudin book, Mathematical Analysis by Rudin. He in chapter 1 he will explain that how the real number construct was constructed by the by Diedekerr. Okay. Any doubt? Then we can move to continuous function. No. Okay. Okay. Is that okay? Anybody has any doubt or any problem with that? What I am explained or anything you want to say? Okay. Okay. It's okay now? Yeah. Okay. So anybody unmute yourself and give me a definition for the function. What is the definition for function? The basic set theory definition. What is the definition for function? And I will take a non-empty set. Okay, E non-empty, because if empty comes, there will be a problem. So I will. There is no problem, which is vacuously a true thing, but normal mind cannot accept that. But I will stick in just a non-empty set. Okay. So what is the definition for a function? Is said to be function. Anybody, please unmute and say what is the definition for the function. Just a definition, clear-cut definition. Anybody, please. No one knows the definition for the function? Okay. Okay. Anybody, please? Okay. Okay, I will say that f is said to be a function from x to y if the first thing is f is a subset of x cross y. Okay, this is the first thing, and for every x we want to find a y belongs to, for every x in x, for every x in x, we want to find there exists a y in y such that x comma y which is belongs to f. Okay, so first of all, f is said to be a function. The first thing is f is a subset of x cross y. Okay, and for every x belongs to x, we want to find a y belongs to y such that x comma y belongs to f. This is the first condition, and the second condition, if x comma y1 and x comma y2 belongs to f, then y1 equal to y2. Okay, so basically a function is nothing but a function is, yes, subset of the Cartesian product x cross y. It satisfies two conditions. For every x, we want to find a y such that x comma x which containing f, and if x comma y and x comma y2, these both elements are present in f, then x1 equal to y1. Okay, so instead of writing x y belongs to f, we use the notation or we denote it by f of x equal to y. Okay, instead of writing x comma y belongs to f, we just notate or denote it by f of x equal to y. Okay, are you clear? Okay, anybody has any doubt or anything you want to say in this thing? Okay, if no doubt means I will just give give a relation. You want to find it is a function or not. Okay, so I given x y, x is x contain x1 x2 x3, y contain y1 y2. These are the functions. These are the thing I given f1 f2 f3. Okay, those thing I given. So anybody say in this three f1 f2 f3 which is function, which is not a function? Anybody please answer this question. Okay, f1 f2 f3, these three thing I given subset of x cross y. In this three f1 f2 f3 which is a function, which is not a function?
F2 is a function, sir.
F2 is a function. How, madam? How did you say that? Which is a function? Okay. So for everything you say, you need a justification, no? Already you see this definition, no? Function definition. Anybody thinks this thing is new, or now only you are seeing this? Then I will just go deeper into function topics, or I will just give an example. I will just move on to continuous function. That's why I'm asking. Is that okay? Okay. F1 is a function or not? Anybody?
No, sir, it's not a function, sir.
Why?
Sir, because x3 has no tuple sum illa, sir. x3 comma some value is not there, sir.
ஓகே, நீங்க தமிழ்லயும் பேசலாம், எனக்கு தமிழும் புரியும். ஸோ பிரச்சனை இல்லை, நீங்க தமிழ்ல கூட கன்வே பண்ணலாம். ஓகே, ஸோ ஐ வில் ஸ்பீக் இன் இங்கிலீஷ், பட் யூ கேன் ஸ்பீக் இன் தமிழ். ஓகே, ஸோ yeah, f1 is not a function because it it does not satisfy the first condition. For every x, we want to find a y such that x comma y belongs to f. Okay, so for x1 we can just find y1, and for x2 we can find y2. But for x3 we cannot find anything. There does not exist any y which contained in f1. So this f1 is not a function, because it does not satisfy the first condition. Okay, what is the first condition? If you take any x, we want to find y such that x comma y belongs to f. But here for x3 there is no such element called y such that which is belongs to this function, this thing f. As a if you think as a graph or just a diagrammatic way of representing function, this is x and this is y. F1 is a function which maps x1 to y1 and x2 to y2, but that in that x we cannot find any element in y which maps x3 to that y. So this x3 is not mapped, or it does not assign anything in y. Okay, so this f1 is not a function. Are you clear? Is that okay? Now, okay. For f2, anybody, please tell me your argument.
F2 is a function because it satisfies the both conditions, first and the second, sir.
Okay. So for every x, what is the y you are choosing?
Y1, sir.
Correct. Okay. So that is the important thing. Okay. For every x, if you choose any x here, that x should assign a element in y. Okay. As a map, we can just plot this as every element in x is assigned to y1. Okay. If I first condition for every x, so if I choose any x in this, we want to find a y in capital Y. So we can find y1 in y such that these elements are mapped to y1. Okay. So first condition is satisfied, and the second condition is nothing but the assign is unique. In the sense, xn assigned to yn uniquely, or x1 is assigned to y1 uniquely. There is no element, or there is no y2 such that x1 is assigned to y1 and also x1 is assigned to y2. This is not a function, because for one input we want one output. That is the thing. No, if I give function is nothing but a program, a process. For that we are giving one input, means that should also give a output. Okay, that output also should be unique. If we give x1, it also give it should give y1, but not both y1 and y2. Okay, so the assignment is unique. Okay, so f2 is a function. What about x3? F3, sorry, F3.
Sir, x1 assigned to two elements y1 and y2, sir. So it's
Correct.
not a function.
Correct. So in this, x1 is assigned to y1 and x1 is also assigned to y2, which is not possible because such a thing happened means that y1 y2 should be equal, but here y1 and y2 is not equal. So x1 is assigned to y1 and x1 is also assigned to y2. So this is not a function. Okay. So anybody want another example, or I can just leave here and go to continuous function? Is that okay? Is that okay? இதிலே போதுமா உங்களுக்கு? Functional definition வச்சிருக்கேன். I given some example. If you want more thing in function, or I will just skip here and go to continuous function. Okay.
It's enough, sir.
Okay. So this is the formal set theory definition for the function. Okay. Just note it down. Okay. So here I won't go outside real numbers. Okay, I will just be inside real numbers. F is a function from F to R. That sorry, F is a function to A to R. That A is a subset of R. Okay, I will just be means my domain and codomains are in the subset of R only. Okay, I'm not going outside of R. Okay, my so I will more focusing real things only. Okay, yeah, and R. Anybody know the definition of modulus?
It's equal to 1 if x greater than 0.
Equal to
1
1
if x greater than 1. Sorry, it's equal to x plus x. Sorry, x greater than 1.
Greater than 1.
Greater than or equal to 0 கூட வச்சுக்கலாம் சார். பாசிட்டிவ் நெகட்டிவ்னு பிரிக்கிறோம் அவ்வளவுதாங்க சார். It's equal to minus x if x less than 0.
Okay.
Less than 0.
Okay, correct. So R with respect to this modulus. Okay, I will not go outside of this modulus. Okay, so in my thing, the metric is nothing but distance between x and y is nothing but modulus of x minus y. This is a metric I will be and I will stick into it. Okay, I will not go outside this. Okay, yeah, normal thing. What is a continuous function? Normally means like what is a continuous thing, or what is a continuous function? What it means? Anybody know the answer? What is the continuous function? Why we want to be more focused on just continuous function, rather other functions like that?
Limiting value is equal to
Limiting value equal to
the value of function at the point at the
Yeah.
given value.
Yeah, nice. But why we want to look more especially in continuous function? Why continuous is necessary? Okay. Anybody? Okay. So, continuous function has a property and has a nice thing to do with that. Okay. So, continuous function has a property called IVP, intermediate value property. Anybody knows what is intermediate value property? Okay. Yeah. First we come to the intermediate value property. Okay. A function f. I will not go outside of R. Okay. R to R. Okay. A function has intermediate property. We call it as intermediate property, IMP. Okay. That is, if f of a less than or less than f of b, where a less than b, then there exists a x which is belongs to a comma b such that f of x equal to r. What is it? Okay. So this function has intermediate property or intermediate value property means if we take any a less than b, f of a, if f of a less than f of b, if we take any point in between this f of a and f of b, say r, we want to find x that is also lies in between a and b such that f of x equal to r. Okay. So if a function satisfies this property, we call this function as this function has intermediate property or intermediate value property. Okay. Yeah. So the first question, you want to draw a continuous function, maybe we can say it as -1 and 2. Okay, you want to draw a continuous function whose value f of 1 is nothing but -1. Okay, f of 1 is nothing but -1 and f of 2 is nothing but 2. Okay, you want to draw a continuous function without touching this x-axis. Can you draw such a function? And my metric is modulus. Okay, it is very important. Can you draw such a function which is continuous but does not passes through the x-axis. Can you draw such a function? It is possible. If I draw a function, anyways, it touches here. Actually, my point is you want to connect this two dot by a continuous curve. Continuous curve. So you can connect this thing or it or not by not touching by not passes through x-axis. Purida? Anybody there? Can you please answer this question? You want to draw a continuous function. F of 1 is -1 and f of 2 is 2. So, which that function that does not passes through x-axis. Can you draw such a function? That is my question. Are they clear? Anybody? Okay. Actually, the thing is, you cannot just without passing through x-axis, you cannot draw a continuous function. If you draw a continuous function, this, and you don't want to touch x-axis, so there will be a break in between this x-axis. Okay, so continuous function is more important because it satisfies the intermediate value property. So only we are more working in continuous function, and day-to-day life everything is continuously moving. The orbits of the sun, everything is just moving continuously, and the time, continuous factor time, it is also moving continuously. So the continuous thing is very important. I will just state intermediate value property, and we can solve some CSIR net problems. Before that, I will write a definition for the continuous. F is a continuous function is said to be continuous at A in R if for every epsilon greater than 0, we want to find a delta greater than 0 such that x minus a less than delta, which implies that mod f of x minus f of a less than epsilon. Okay, I will just define what is continuous function. F from R to R is said to be continuous. At a point A belongs to R if for given any epsilon greater than 0, we want to find a delta greater than 0 such that the x is near the distance x x from A, the distance between x and A the distance is less than delta and the output distance f of x minus f of a, which is less than epsilon. Okay. So I draw a continuous function. So choose a point A. So f is a function. So for A, there will be an output f of A. Okay. So in the codomain, we want to draw a epsilon ball. Epsilon ball means means set of all points whose distance from f of a is less than epsilon. Okay. So for this epsilon ball, we want to find a delta ball around A. Okay. First, we want to make an epsilon ball. We want to choose an epsilon ball with a f of A is a center and radius epsilon. Okay. We want to choose first epsilon for every epsilon. So for any epsilon we are choosing, we want to find a delta. Okay. So what it means by this? So we want to find a neighborhood. We want to find a ball around A such that the ball should contain in this neighborhood. Example. So this is the ball, epsilon ball. So we want to find a delta ball in the domain. So we want to find a delta ball, A minus delta, A plus delta, which totally contained in this ball. That is the meaning of this definition. Okay. So it should be closer. It should be more close to A also. Okay. It also be more close to A. So you want to find such a delta for epsilon. Okay. And the thing here is this delta ball is depend upon the epsilon where you chosen and the point where you looking after the continuity of the function. Okay. Actually, some author will mention the delta of epsilon comma a. What it means that we are choosing this delta which depends upon the epsilon ball and the point where we are speaking, we are trying to prove or things go on A. Okay. So are you clear? So that in that neighborhood, if you choose any x in this neighborhood whose output will also lies in this epsilon ball. Okay. So the clear way, f is a function. R to R, which maps. So here a point A. So that point f of A is mapped here. So in ball in R2. So if you construct any ball, epsilon ball, if you construct any epsilon ball, we want to find a delta ball around A such that this delta ball lies inside that epsilon ball. Okay, so for given any epsilon, we want to find a delta such that that delta ball will sit inside this epsilon ball for that epsilon. Is that okay? Is that clear? So for given any epsilon, we want to first they will give a epsilon ball center at f of a, radius epsilon. So we want to find a delta ball in a domain such that that delta ball should lie completely inside that epsilon ball. That is the thing I written here. Okay, is that okay? Anyone has a problem or anything you want to say? This is the definition, and there is an improper way that if you draw continuous line or continuous thing in your hand without taking, you want to draw a line without taking your hands, then it is continuous like that. No things. Is that okay? This definition is clear. No. Anyone has in you have any doubt or anything you want to say, or you didn't get anything also? It's okay. I will explain. Is that okay? Okay. Is that okay? Anyone has a problem? Okay. F of x equal to 1. I will give the epsilon as 0.5. What is the delta? Can you say me for epsilon equal to 0.5, and I will just fix a point. A is nothing but 0. Okay. F is a function from R to R, just f of x equal to 1. Clearly this is a function, no? So f of x equal to 1 is a function and the point A equal to 0. I given that epsilon equal to 0.5. So can you say what delta we can choose that it will lies inside the 0.5? My question is clear, no? I given the epsilon, you want to find a delta and you want to argue that why this delta is valid. That's the thing I'm asking at last. Is that okay?
Yes, sir.
Yeah. So I will give some time. Please say what is the delta will be. We can choose that. Actually, my sir will say that the hardest thing or the toughest job is to find a delta corresponding to a x naught. That is the hardest thing. Anybody, please say what delta will be worked out, means will be valid there. Anyone? Can you please respond? Because without interaction, the class will not go well for me. Okay. If I choose delta equal to 1, okay, if I choose delta equal to 1, so uh, so we want to be in the real line of center 0, radius 1. So it will be plus 1, in between plus 1 and minus 1. Okay. The function will maps only to 1. Okay. So take x belongs to minus 1, comma 1. We want to look mod f of x comma minus f of 0. What is f of x? What is the value of f of x? What is the value of f of x here? What is the function I given? Anybody, please? What is the function I given? Constant function 1, no. So f of 1 is also 1 and f of 0 is also 0, which is equal to 0. But we know that epsilon is greater than 0. So which is obviously 0 is obviously less than epsilon. Okay. So the delta is delta can be 1, and more precisely it can be any delta, any number, positive. So we can choose any positive number such that, because we didn't use the delta neighborhood here. Okay. So it is clear that this thing f of x minus f of 0 will always be 0. Okay. And we are choosing epsilon greater than 0. So epsilon is always greater than 0. So we can choose any epsilon. Okay. So I will write a CSIR net question on continuous function. So you want to answer that question. Okay. CSIR net 2017 question. The question is state like, let x s be a function from R at such that the exists epsilon greater than 0, such that for any delta greater than 0, mod x minus y less than delta, which implies mod f of x minus f of y less than epsilon. Then if R take R, f is continuous, then f is unique uniformly continuous. Okay. R to R if is bounded C P. Yes. R to R F is constant. So I will give you time. So just remember what is the definition of continuous function I given and just tackle this question, okay? This is a CSIR NET question 2017 question. If anybody has any doubt or you are not uh, you are not getting understand the question or any problem you have, please convey to me. I will just help you. I will glad to help you. Anybody? Anybody solve this problem? Or anyone has any doubt like that? If you have means, I will glad to help you. The thing is, if you are not choosing A or you are saying A is false means you want to give a counter. So that I want to type there. Okay. So if you eliminating yeah option means you want to give a counter. Okay. That is the best way. And you are proving if you are saying A is correct means you want to you try to prove that why it is correct. Like that you try to prove that. Okay. Anybody has any doubt or anything you want to say? Anyone try to answer this question? Is that okay? You have any doubts? Anyone? Any participant? Is anyone response? Or I won't go to next question. If you have any doubt also, you can just ask me. Okay. Okay, no one. So the question says that we want to collect a function here. That the function satisfies this condition. The condition is there exists a epsilon greater than 0 for every delta greater than 0. This is x minus y, which is less than delta, which implies f of x minus f of y, which is less than epsilon. Okay. What is the definition of for continuous? F is said to be continuous at A, which means if, what is the definition? For every epsilon greater than 0, we want to find a delta which is greater than 0 such that mod x minus a less than delta, which implies mod f of x minus f of a, which is less than epsilon. Okay, this is the definition, formal definition for the continuous. But you can see that in the place of for all, they replace epsilon. Okay, actually these two things for all there exist. In mathematics we call it as a quantifier. Okay, the first this is existent quantifier, this is universal quantifier. For all is universal quantifier, there exists is existence quantifier. This two quantifier is the main thing in mathematics or in logics to claim something. Okay, if you swap those two things, if you swap those two quantifier means the meaning of this sentence or this statement will be totally different from the original statement. Okay, so they given that for there exists an epsilon for all delta x minus y less than delta, which implies that f of x minus f of y, which is less than epsilon. Okay, the first option, the set S is set up for continuous function. They are claiming it as set up for continuous function, but A is not a correct option. So if you are eliminating A, then you want to give a counter example or counter example for that. Okay, For that, I will give f of x 1 if x is rational and 0 if x is irrational. Okay, I will give this function, and anybody know what is the name of this function? F of x is defined to be 1 if x is rational, and f of x is defined to be 0 if x is irrational. What is this function? Anybody know this function? So you don't know what is this function? Dirichlet function. You know Dirichlet function, no? This is a famous function. Dirichlet function. Dirichlet is a mathematician. He is the first. Why he constructed this function means in ancient time they believe that every function can be plotted in graph. So they believe such a thing in ancient time, but Dirichlet is a mathematician who defined this function and who proved that this function cannot be plotted in graph because this q and q complements are denser in R. So if you try to plot this function, or if you have any graph, any graph plotter like that, means you type this function, it will show that show two lines, straight lines, because the rational and irrational things are or denser, so you cannot look this as a dotted line. It will look like a straight line. So this is the first example given by Dirichlet that this function cannot be plotted. Okay, so you can plot x square x like that. You can plot, and we can plot constant functions, but this function cannot be plotted. Okay, so we want to find an epsilon. So that epsilon will be work for all delta. Okay, so f of x minus f of y. Okay, if x and y both are rational, then what is the output? If x and y both are rational, means it will take the output as 1 minus 1 and it will be 0. Okay, if similarly if x and y are both are irrational, means the output will be 0 minus 0, we will get 0. Okay, if we take x to be rational, y to be irrational, means the distance between the output distance will be 1. Okay, 1 minus 0, it will be 1. So here for this function we can choose any epsilon which is greater than 1. Why? Because the thing is in output. Okay, f of x minus f of y. If x and y are both in rational, means we will get 0. If x and y are both in irrational, also the output distance will be also 0. And if one is rational, one is irrational, means the distance is nothing but 1. So if we choose any epsilon greater than 2, then this statement will be valid, and this function is not continuous. So option A is not correct. And if option A is not correct, means option B is also not correct. Why? Anybody know that the thing f is uniformly continuous, which implies f is continuous. Okay, so the equivalent statement is f is not continuous, which implies f is not uniformly continuous. This is a contra-causative statement. P implies Q. If P holds, then Q will be there. Okay. If P, then Q. If the hypothesis of P is true, then the result will be Q. Okay. So the equivalent version is that the contra-causative statement is negation of Q implies negation of P. This is a contra-causative statement. Okay. So if Q is not there, then P is also not there. Okay. If Q is there, if P is there, then Q is also there. If P holds, then Q will be there. But the contra-causative statement is if Q is not there, then P is also not there. This is the contra-causative statement, the equivalent version of this statement. If this is true, then this is also true, and if it is false, this statement is also false. Okay, so f is uniformly continuous. We know that f is continuous. The contra-causative statement is f is not continuous, f is not uniformly continuous. This is a contra-causative statement. So we already show that f is not continuous, then which also imply that f is not uniformly continuous. So the same counter example will work in B. Okay, so B is not correct. Okay. And D option, can you guess about D option? D is correct or not? Anyone? And the hint is on the board. You want to give a counter that f is not constant. You want to show there is a non-constant function in this set. What is the counter you can give? Anybody? The thing is on the board. Anybody? What is the counter we can make here?
Constant functions are continuous.
Okay, but you want to say that here there is a function. That function is not constant, but you want to choose a function here. That function is not constant, because if you claim D option is correct, means f should be constant function. Okay, but you want to find a function here which is not a constant, that will be counted for D. What kind of function we can choose? That is the question I asked, and I also reply that the thing is on the board. You can think the Dirichlet function. Dirichlet function is also a member in this. I'm right, no? Dirichlet function is also a member of this set. But if Dirichlet function is constant, anyone? Is steady state function is constant?
No.
No. So D option is also false. So the option is C is the correct option. Okay. So I will just prove the why F is bounded. I will prove it now. Okay. So we want to prove that F is bounded. We want to prove that if F belongs to S means then F is bounded. What is the definition for bounded? F from R to R is said to be bounded. If anyone? What is the definition for a bounded function? Anyone knows, or I will just state that. Okay. So f is a function. We want, if we say that f is bounded means we want to find a positive number m such that mod f of x is less than or equal to m for all x belongs to R. If you can find such a m, then f is said to be bounded. Okay, this is the definition for bounded. Okay, f is said to be bounded if there exists a m greater than 0 such that mod f of x is less than or equal to m for all x belongs to R. Okay, this is a definition for the bounded function. So we want to show that f is bounded. To show f is bounded, we want to find a m. Okay, so mod f of x. So we want to bound this by a constant m. Okay, but we don't know what is that constant. But I'm doing small change like f of x minus f of 0 plus f of x, f of 0. Okay, by triangle inequality we can write this as which is less than or equal to mod f of x minus f of 0 plus mod f of 0. Okay, but here the x term is always varying. What is the bound we can expect here? And please note this thing. Given epsilon, the distance can be any distance. The meaning of this for any delta means that x and y can be large enough. Okay, can be smaller also. The distance is not matter here. Okay, that's the thing you want to identify. Okay, so what is the bound you can give here? And epsilon, you know about epsilon, and you know about those things they are given. Okay, only thing you want to find that you want to find such an m. How you can find such an m? Anybody? Just see that. Okay. So here we know that epsilon, if epsilon is a fixed quantity, no. So we can just bound this by less than epsilon plus mod f of 0. This is the m I can choose, and epsilon is strictly greater than 0. Mod f of x is greater than or equal to 0. So we can claim that this m is also 0. So if you choose m as epsilon plus mod f of x of 0 means it will be a bound for f of x. So this is bounded. F is bounded. Okay. So x is nothing but set of all bounded function. Is that okay? Anything you want to claim or anything you want to say here? You have any doubt? Can I move to the next question? Okay. So this is a geometrical question. You can answer this. 2020. CSIR NET 2020 given F and G continuous on 0, 1 such that f of 0, f of 1 equal to 0 and g of 0, g of 1 equal to 1 and f of 1 by 2 is greater than g of 1 by 2. Which of the following are true? A, there does not exist any t in 0, 1 such that f of t equal to g of t. There exists unique t belongs to 0, 1 such that f of t equal to g of t. There exists at least two t belongs to 0, 1 such that f of t equal to g of t. There exists infinite number of or infinitely many t such that f of t equal to g of t. Okay. So I will give 5 minutes. So think geometrically. So you will be get it. I think so. So try to solve it. Okay. If you have any doubt or any clarification, means please ask. I will just I will glad to clarify it. Anyone answered this? Anyone tried this or any conclusion you got? Okay. So this kind of question we call geometrical questions or some easy questions we can tackle in CSIR net. This you don't know need to know the definition of continuous function like this things and all. If you think logically, you can just answer this question. That kind of question it is.
Option
It's
C, sir.
option C. Okay. Nice, nice, nice. Okay. Any other? One set option C. Any option you want to you think correct or wrong like that? Any other? Okay. Okay. So this is a graphical and geometrical question. This is okay. So if you see such a question in CSIR net, please don't skip. Okay. So 0, 1. Okay. F is a function from 0 to 1. They given that f of 0 and f of 1 is 1. Okay. So this is f of 0 and f of 1. 1. So g of 0 and g of 1 is 1. G of 0, g of 1 is 1. And additional thing they given that in 1 by 2, f of 1 by 2 should be greater than g of 1 by 2. That means f of 1 by 2, g of 1 by 2 can be negative, but I will just stick to positive. Okay, so this is f of 1 by 2. G of 1 by 2 should be below f of 1 by 2. This is f of 1 by 2. G of 1 by 2. Okay, so these are the data they given, and f and g's are continuous function. So think that you want to draw a line without a break, without any jumps or breaks in that line. So you want to connect f of 0, f of 1, and f of 0, f of 1, f of 1 by 2, and we want to connect g of 0, g of 1 by 2, and g of 1. So we want to connect these things. Okay, and the f and g's are continuous. They are asking f of g equal to f of t equal to g of t. We want to find t such that f of t equal to g of t. What is the meaning of this thing? Graphically, what it says? Anybody? What is the meaning of this thing? When the output of two graphs are equal.
The graph should intersect at a point, sir.
Yeah, correct. The graph should intersect at a point. If I take a graph like this is some phase and this is some psi, means this phi and psi intersect a point. In that, phi of x equal to psi of x. Phi of x equal to psi of x. So it is nothing but the graph should intersect. So we want to find intersect point. The basic thing is here we want to find a points which that graph of f and graph of g should be coincide. Okay, if I draw a function like this, like an arc from above and below. So clearly it connects these three dots and it's connect these three dots. Okay, and I drawn continuously, so you no need to check it is continuous. So say that these two graphs are coincide or not. The thing is, these two graphs are coincide or not. That is the thing. Or meet any point. Are you getting my argument? Is that okay? It is clear, no? So it meets somewhere. The 2 points are meeting in 2 different points. But what is the option? A says there does not exist any t. So there does not exist any t such that f of t equal to g of t, which is not a correct statement, no, because I drawn two continuous functions f and g which exactly coincide 2 times. Okay, so f of it coincides in this point, say x1 and x2. So option A is not correct because option A says that the two graph is not coincident. Okay, the two graph not passes to each other. Okay, like that option A says, but I drawn a function that functions satisfies this hypothesis. F of 0, f of 1 equal to 0. F of 0, f of 1 equal to 0 and g of 0, g of 1 equal to 1, g of 0, g of 1 equal to 1, f of 1 by 2 is greater than f of 1 by g of 1 by 2. So like the hypothesis of these two functions are satisfied, but these two functions coincide. So option A is not correct. Like that. For option B, what is the counter? Option is correct or not? Can anyone read just a option? What is B say? B என்ன சொல்லுதுன்னு யாராச்சும் சொல்லுங்க பாப்போம். B statement என்ன சொல்லுது? What is the B statement state? என்ன சொல்லுங்க? What is the meaning of B statement? யாராச்சும் ஒருத்தர் அன்மியூட் பண்ணி சொல்லுங்க பாப்போம். Kindly. Okay. So what is the meaning of this symbol? யாருக்காச்சும் தெரியுமா? What is the meaning of it? Anybody knows that? What is it means? This is you know that there exists. What it means? Exclamatory mark. There no. இது பத்தி யாருக்காச்சும் தெரியுமா? So this the meaning of this is there exists unique. So it should exist and the existence should be unique. There is no other element which satisfies this condition. Okay, so the option B states that there exists a unique t belongs to 0, 1 such that f of t equal to g of t. Okay, but here you can see that there exists 2 points x1 and x2 which coincide, but the points are different. The uniqueness is not valid. No, so option B is not correct option because I shown that it is not unique. Okay, actually there exists and unique. This statement is it's very crucial and very tricky because it involves and logic that unlogic also. Okay, so it says that there exists and unique. Okay, if there exists means no problem. If you fail to show it is unique means the statement is not true. Okay, so B statement is not true. Okay, just leave C and we move to D. There exist infinitely many t's such that f of t equal to g of t. So this statement is true or false? Anyone? D option is true or false? Anyone please answer? Okay. Actually, the same counter will work out because x1 and x2 are 2 points. That in that point only the two functions are coincide. Remaining and all the function is not coincide. Okay, so here they given there exists infinitely many t's. So, but here we find only finite 2 points only. We find that the function are coincide. So D option is false and C option is the correct option. Okay. For proving C option, we need a concept called intermediate value theorem. For the continuous function they given because of we want to use intermediate value property, so they are given the continuous thing and all. Okay, so we can prove this thing. So I'm going to prove that C option is the correct option. So for that, I am defining a function g of t, which is nothing but f of t minus g of t. Okay. So here I'm using algebraic of continuity. We know that no. So if f is continuous, g is continuous, f plus g is also continuous, f minus g is also continuous, and product of continuous function is also continuous. Okay, so I am using f minus g is continuous. So this function is this h function is continuous function and h of 0. H of 0, what h of 0 is? F of 0 minus g of 0. F of 0, the value of f of 0 is 0 and the value of z of 0 is 1. So we get minus 1, which is less than 0. And we want to use f of 1 by 2. So f of 1 by 2 is nothing but f of 1 by 2 minus g of 1 by 2. Sorry, g of 1 by 2. Okay. What is the sign of this? Whether it is a positive or negative? Anyone answer this? Whether it is positive or negative?
Positive, sir.
Correct. Because of this, f of 1 by 2 is strictly greater than f of g of 1 by 2. So this is greater than 0. Okay. And h of 1. What h of 1 we get f of 1 minus g of 1, we will get minus 1, which is less than 0. So h of 0 less than 0 and less than h of 1 by 2. H is continuous function, so there exists a point. Okay, so h is continuous function, so there exists a x belongs to 0, 1 by 2, such that h of x equal to 0. If h of x equal to 0 means what will be happen here? H of x equal to 0 means f of x equal to g of x. If h of x equal to 0 means h of x equal to f of x minus g of x, which is nothing but equal to 0, which implies f of x equal to g of x, and this is if and only if. So in between 0 and 1, in between 0 and 1 by 2, we get a point x such that in that point f of x and g of x values are equal. So you can verify here, in between 0 and 1 by 2, you get a point x1 such that in that x1, the points, the two functions g and f are coincide. Okay. Similarly, h of 1 by 2 is okay. By using same intermediate value theorem, we can say that h of 0 is less than 0. H of 1 is less than 0 and less than h of 1 by 2. So here I am comparing these two things. H of 1 by 2 is greater than 0 and h of 1 is less than 0. So h of 1 is less than 0 and h of 1 by 2 is also it is greater than 0. By using intermediate value property, so I will say it has h1. So by using intermediate value theorem, we get x2 belongs to 1 by 2 comma 1 such that h of x2 equal to 0. So here we get 1 by 2 in the place of 1 by, in between 1 by 2 and 1, we get a point. In that point, we get a point x2. In that point, the function of f of x2 and g of x2 are equal, which means in between 1 by 2 and 1, the functions are coincide. Okay, are you clear now? So this is a geometrical question. Okay, and the points, it should not the points, it's not unique in the sense. Okay, so here we can draw a function in between 0 and 1 by 2. There are many fixed points. Can anyone draw a function that f of 1 by 2, g of 1 by 2? Okay, can anyone draw two functions f and g, but it should coincide infinitely? Such a function is valid out here. Infinite times it should coincide. That's the thing. Can you draw such function? It is possible to draw such function here. The thing I am asking, are you getting my point? You want to draw a function, two functions, which is coincide, satisfies this hypothesis and coincide infinitely many times. Can you draw? It is possible to draw or not? That's the thing I am asking. Anyone? Yeah, please. It is possible to draw or not? That's the thing I am asking. So in infinitely many points, it should coincide. You want to draw a two function such that infinitely many points, it should coincide. So I will draw a function like that. So in between I draw one straight line. So I draw a f function like it connect here and moves up and go down. So it follows this straight line. Okay, this is f function. I'm drawing g function from here, connect this line, travel here and goes down and move up. So in this interval, you know that this interval is uncountable because say any point like 1 by 2, this is 1 by 4. So in this interval, the function is nothing but a constant. Okay, the function is nothing but a constant function. Say it takes a value 1 by 2. So you can draw a function, f function, which which satisfies this hypothesis. F of 0 is 0, f of 1 is 0, and f of 1 by 2 is strictly greater than g of 1 by 2. So this function satisfies this condition, but it has uncountably many points. The two functions coincide in uncountably many points. Okay, so such a function is also valid and countable times is also valid. Okay, we can draw a function which coincides exactly countably infinite times. Okay, such a function is also you can you can construct such a function f and g also. Okay, I will just give a homework that you want to find two functions f and g such that satisfying this condition and f of x equal to f of g of x equal to f of x. If you collecting all such x, this set should be infinite, countably infinite. Infinite and countable. Infinite and countable. Try to construct such function. I will give this as a homework. Okay. So try to construct two functions satisfying this hypothesis, and if you collect all the coincident points, that should be countable and infinite. Okay. Anybody has any questions or anything you want to say? Is that okay? So, can I move? Any doubt? Okay. Okay. So, next question 2020, 2014. 2014. Let f is a function from 0, infinity to 0, infinity. Be continuous. Which of the following are correct? Yes, correct. There exists a x naught in 0 comma infinity such that f of x naught equal to x naught. B, if f of x is less than or equal to m for all x. If x of x naught, if f of x naught equal to less than or equal to m for all x belongs to 0 comma infinity for some m for some m greater than 0, then there exists x naught in 0 comma infinity such that f of x naught equal to x naught. See, if f of if there exists x naught belongs to 0 comma infinity such that f of x naught equal to x naught, then it must be a unique D f does not have x naught such that f of x naught equal to x naught unless it is differentiable on 0 comma infinity. Okay, so I will give 5 minutes. So this is also a graphical type question. Please try to answer it. If you have any doubt, please ask. Anybody? Just try to plot the graph. In CSIR net part B question, if you give correct counter means you can just pick the right answer. So counter is counter strategy is very good for CSIR net part B questions. If you are trying to attend part B means make sure you are best in giving counters.
Option B, sir.
Option B. Okay. So you eliminate option A. What is the reason for option B? Can you please say that? Okay. Any other? Any option? Actually, this is also a problem similar to previous problem. The previous problem we done know, but they are in previous problem they given two functions f and g, but here they given only one function, but there is another function. If you read this question carefully, you can identify that what is the another function they given. Okay, actually here we want to use same logic only. The methodology we used in previous theorem, that the same method only, but we want to find another function g. What is that another function g? That is the thing we want to know. Okay. Anybody? Okay. So no idea. Okay. So I will just solve this question, and I think this is the last question. I think so, because time is now 4:55. Okay. Actually, they are asking about a point x naught such that f of x naught equal to x naught. So the another function in the
Yes, sir.
Sir?
I'm audible?
Yeah, yes, sir.
Yeah. So maybe I think option C is correct.
Option C is correct.
Sorry. Option B. Sorry, option B.
Okay. So, okay.
Can I explain?
Okay, sir. You can.
Yeah, I think that is it's not representing a point which is fixed by the f. Correct.
Okay.
So which is meeting of the line y equal to x.
Yeah.
Yeah. So f of x is bounded by f.
Yeah. Correct.
So in my point, so whatever the value in the domain, it is not bounds. It is not exceed f.
Okay.
So suppose it started from 0 to 0, so that means beginning point of the domain 0, and the codomain is also 0. So
Okay.
I guess the first value of f is more than 0.
Okay.
So it commonly crosses some value of m.
Yeah.
So it crosses the y equal to x line. So we can get the point which is fixed by the function f. And also it is not unique because it have many times it crosses the y equal to x line.
Okay. Okay.
So I think B is correct. I don't know whether it's correct or not.
Okay, but you are tried, no, yeah, and your logics are under correct, but you want to make more precise argument, like touching work, okay. So your logics are all correct.
Just I
Yeah,
thought in view of
yeah.
geometry only, sir.
Yeah. Your logic is totally fine, totally correct, but yeah, that is good thing. Okay, so yeah, geometric way of thinking is so nice.
And also option A is wrong with respect to my value of the function. That means that f of 0 is more than 0 means it never come and process the y equal to x.
Okay.
Suppose it's not bounded. So option A is also false, I think.
Okay.
So I go to B. Also A and C are false. I don't know about D.
Okay. So I will explain. Don't worry about that. Okay.
Yes. Yes, sir. Thank you, sir.
Okay. Thank you. So you want to draw a function. Actually, you can think this as an identity function. Okay. That g of x is nothing but x function. So you want to draw a function which does not coincide with this identity function. Such a function exists. It is valid that we can draw such a function. Say yes or no. We want to draw a function which should not intersect with this identity function. G of x equal to x. Such f of x is exists or not. You know what is parallel line? The hint is, I given the hint. So if you consider the parallel line, say this line, the line equation is f of x equal to x plus 1. And you can verify that these two lines are parallel, but f of x equal to x plus 1 is not have any point in this identity, or it does not coincide with this identity function. Okay, so suppose f of x equal to x plus 1. Suppose if there exists such a function, suppose that there exists x naught such that f of x naught equal to x naught, then what will happen? F of x naught is nothing but x naught plus 1 equal to x naught. Here we will get 1 equal to 0. If you cancel x naught, you will get 1 equal to 0, which is a contradiction. So it won't be happen, no. In our real line, 1 is not equal to 0. But here, if this function has a fixed as a point such that f of x naught equal to x naught, this point we call it as a fixed point. If such a function, such a point exists, means we get a thing that f1 is equal to 0, which is not possible for this function. So this function satisfies this hypothesis but does not have any fixed point. So A option is wrong. Similarly, if there exists x naught such that f of x naught equal to x naught, then it must be unique. So C option is true or false? Anyone? If it is false, means you want to give one counter. One counter is enough to eliminate C option. Anyone? You want to give a function, sir?
Just the identity function, sir.
Yeah, correct. F of x equal to x. Simply an identity function. If we take an identity function has infinitely many fixed points because it fixed all points. So C option is not correct. D option? Anyone? What is the answer? Whether it is true or false?
Expect to see these also false.
D is also function. Counter?
Take an identity function, which is
Same identity function. Okay. So if you very good enough to give counter, means part B is such a easy thing. You can solve it because no need to prove B option. If you eliminate 3 option, you will get B option right. Okay. So for CSIR NET, maximum those who are scoring very good mark in part B, that means they are very good in giving counters for those options. Okay. So taking f of x equal to x, we will get we know that f of x equal to x is differentiable function, but they're saying it don't have any point which is fixed, but it has infinitely many fixed points. So D option is false. So B option is true. So I will just make the proof for it. Okay. I will just prove why B option is true, and we will just end this session after completing this proof. Okay. So we want to prove g of x less than or equal to m. Okay, sorry, f of x less than or equal to m is bounded by some m. So actually concept is this is an identity function, and if you this is the m function. So you want to draw a continuous function, but you should not pass through this identity function. Such a function exists or not? Geometrically, if you start with, above the function, now, so you want to go here, but after that you should not cross this line. So you should just bend that, okay? Because you should not cross this constant, okay? You should not cross this line, okay? So it should pass us this identity function. So if you move down, means at 0 you want to fix a point, okay? So you want to go like this or like this, because in 0 you want to give above only, okay? Either you can, for f of 0, you can give 0. If you give 0, 0 is a fixed point. If you think f of 0, if you give f of 0 greater than 0 means, here means, if you connect this line means you should not cross that m. You should go like that. One time you should pass us that fixed function f of x, g of x equal to x. Okay, this is the geometrical logic behind the scene, but we will prove that. Okay, so we similarly we can define f of h of x equal to f of x minus x. Okay, so h of 0 equal to f of 0, which is greater than or equal to 0. Okay, and h of m. I take m because m is the main hint here. So we take m. H of m equal to f of m minus m. But f of m minus m, what is the value of f of m minus m? Which is less than or equal to 0. Am I right? No. So if h of 0 equal to 0 means 0 is a fixed point. Okay. Then there is nothing to prove, because if this term is 0 means 0 is the fixed point. If take x naught to be 0, if h of m equal to 0, if h of m equal to 0 means, then take x naught to be m. If this is 0 means 0 is the fixed point of f. If this is h of m is 0 means m is the fixed point of this. Okay. If this both the two if this is positive and this is strictly negative means, in that case we can use intermediate value theorem. Okay. If h of 0 is greater than 0 and h of m is less than m, then by intermediate value theorem, there exists a x naught in between 0 comma m such that h of x naught equal to 0. If h of x naught equal to 0 means f of x naught minus x naught equal to 0. So f of x naught equal to 0. This is by intermediate value theorem of h. Okay. So this is a proof behind why B is correct. So B is correct option. Okay. So here I'm just ending my session. And Murugan sir?
Yeah. Dear participants, if you have any doubts, questions, you can ask to Vignesh sir. Please unmute your mic and speak with sir. Yeah. So if you don't have any doubts, I thank again Vignesh sir for giving the valuable lecture. So now I invite my co-coordinator, Dr. Shivakumar sir, to give the vote of thanks for this workshop. Dr. Shivakumar sir. Dr. Shivakumar sir, are you there? Okay, so I think sir is not there. So on behalf of him, once again I thank. First of all, I would like to thank my management for the opportunity to conduct such a workshop for the participants. And secondly, I would like to thank my department HOD and the school team for giving the approval of conducting this kind of a workshop. And foremost, I wanted to thank Pachepan for accepting the invitation to give a talk on this workshop. And also, I very much thank for the valuable information shared on algebra in the morning session. Even though he was in some other busy schedule, so he nicely managed the sessions with with a lot of inputs on algebra, and then how to see the problems in CSIR as well as in other accommodative exams. And also the second session is very much informative. It started from the basics of number theory, and it went up to the analysis part by Vignesh. I thank Vignesh for these very the superb lectures. So even the non-math student can start with your the teaching. They can learn up to this level. So it was very much needed for every mathematics students who are studying BSc as well as an MSc to know what is function first of all. Then only they can understand what is continuous functions, what is uniform continuous functions. So they have to see the function clearly. So that is actually clearly we can see from your lecture. So thank you so much again. In future, I definitely invite people to VIT to give such a lectures to our students. So again, I'd like to thank all the participants for registering for this workshop and gaining the valuable information from this workshop. So one more information to the participants. I sent the Google form for about the workshops. So kindly fill the Google form to get the certificate. Kindly fill your name, register email ID, institutions, and also your destinations. You'll get the certificate within a few days. Yeah, so this is the final information that I wanted to share. If you wanted to contact the speaker, that is Pachepan sir, then I'll send a link of his institute in your mail ID, as well as I'll share the WhatsApp number of sir. And if you want the contact number of Vignesh also, I'll share the contact number of Vignesh. You can get a help from him if you wanted to join things like IIT or AAC or any other institution in India. Thank you once again for attending this workshop. Now we will close the sessions. I think the afternoon session was not recorded, and the morning sessions were recorded. I'll share the link of the morning session. I'm not able to share the link of the afternoon session because it was not recorded. So thank you, Vignesh. Thank you, Vignesh, for having this 3 hours continuously. You have given the lectures. Thank you once again.
Thank you.
So participants, now you can leave the meeting.